I'm definitely not an architect. In fact, I'm a broke engineering undergrad, so how did I end up going through all of this to get to that? So I developed the pregnancy with the idea of building a voice-controlled house for various reasons, best known to me of course. Well, meant for your entertainment anyway. Now, as the broke engineer I am, I definitely was not going to try embedding voice control for my own house where I live. That's too expensive and simple. Considering my options, why not just build a model house and voice control that? Isn't that easier? Well, I soon came to find out it's easier but not easy. Definitely not easy. I had about 73 gig of raw building footage, so stay to the end to see how things went down, literally. Now onto the project. First of all, I had an idea of how the electronics would work after coming across a speech recognition module from Elec House, which is a speaker dependent module, meaning it's meant to work with one voice and tone. For example, 0 and 0 are two different commands. Now, because it's trainable, it fits for this application as it can carry up to 80 instructions and it can load 7 instructions at a time in groups. I thought it was going to be easy at first, but trust me, this is what killed me the most to get set up. Moving past my thoughts about the electronics, the biggest problem, which is the model house, showed up. As I said, I'm a mechatronics undergrad student and not an architectural student, and so I did what I knew how to do best: YouTube. How to make a bungalow model house. After looking it up, I got a better grasp of the different processes on how to get it done so that I could upgrade my previous carton house building skills from my childhood days. After looking at and watching several videos, I came up with a design with 5 rooms in particular: a parlor, dining, kitchen, bedroom and garage. I drafted it shabbily and started laying it out with dimensions so I could have a floor plan, wall height and roof design, which I generously obtained a lot of the looks from this video. Now to today's sponsor, me. If you like my content and building videos, thank you for watching, and to my 226 subscribers out of the description of this video, I appreciate every one of you, honestly. Make sure to like, subscribe if you haven't, and turn on post notifications. I got tons of new stuff I'm working on, and your support helps grow the channel. Someone please give me a 3D printer. I'm begging, literally. But yes, make sure to drop a comment on future build ideas and what you think of this build in particular. With my inspiration tank full and using the design template, I got to working on the house. For the house construction, I used straw board, a lot of hot glue, uhu glue, cardboard sheets, my trusted cutter, scissors, some acrylic boards to save me from cutting my table, and a metal ruler. So basically, technical drawing tools, woven protractors, set squares, a pen and pencil for marking, and that's about it. I can't show the whole process in this one video because it was quite a lot of building since I attempted to build the model house myself. So I will release a video with the whole process sped up as an ASMR video because it felt oddly satisfying to watch. I also got some fake grass sheets, interlocking pattern sheets and tiny model plants to decorate everything. So here's the building montage. Once the base of the house was established, I went on to making the walls and testing the servos with the doors. Now for the electronics. Here is the fitting design I made for the project, which consists of 2 LiPo batteries for power supply, an Arduino Uno, which is the microcontroller acting as the brains of the system, 5 LEDs and 5 SG90 servo motors. Each room would have 1 servo and 1 light, so the lights could be commanded to come on or off, and either a door, a window, or a garage door for each room will be commanded to open or close. With the plan in my head, I started testing the servos and how they fitted with the doors and windows, which you can obviously see here that it looks like crap, but I promise you it does get somewhat better by the time I'm done building. As for the windows, I used a transparent film cut to the right size and a frame out of barbecue sticks for them, so you could see the lights come on from outside. After assembling all the walls, testing the position range for all the servo motors and the LEDs which work without resistors to drop voltage from the Arduino, which normally you would need resistors, but they worked, so I left them like that. Then I checked out everything and all the individual components were working. As a good engineer I am, I went to YouTube to find out how to use the module from the Elec house, and Electronoob's channel provided to be very useful. I had 5 rooms, each with a light and window or door, which needed to be voice controlled. Now that posed a problem since the Elec house voice recognition module actually only worked with 7 different train command instructions at a time. Now that's where the video from Electronoobs gave me an idea, which was a sequence where you need to complete a set of instructions by sequence. After having issues getting the module to work in the first place, which was on me because I forgot to change the serial port settings on the IDE, dumb shit. Considering I read the entire manual and datasheet thingy for it, I just had to waste time on that alone. But here's how I got the module to work with more than 7 instructions. So let's do the math. So I had 5 rooms each with 2 things to control, that's 10 instructions. I separated the instructions into this format. Instructions to identify where the commands will take place, and then the actual commands. So this is how it worked. First of all, the module will load the first set of instructions. These instructions will be able to call out the location in the house you want to control. Then, after an instruction has been recognized, it would clear the instruction set and then load the next set of instructions after it was done. The next set of commands were instructions which could be light on, light off, door open, door close, and possibly more. Once the instruction was carried out, it would clear the instruction set and load the initial set after it was done. This allowed me to control and call the location, then give an instruction to the LED or servo in that called out room, and then repeat the whole process again and again. So it had to have the sequence of the location and then the instruction, and then you go back to the location and instruction. For example, you would say parlor and then you say light on, then you say parlor and then you say light off. So I'll be going deeper into the codes for those interested. Essentially, while practicing, I could only use zeros and 1 because I'm very bad at keeping my tone consistent. So I use 0, 1, 2, 3 up until 9. I think so in the code is written there. So I used numbers which are simpler and have shorter syllables to speak, to train it, and to get like actual performance data from it. So here's the explanation of the code. Essentially, to use the module, you need to get this voice recognition v3.h library, which you get from the Elec house website. And how to use it, you can go to examples after installing the library and go to voice recognition v3 and go to VR sample train. So when you run this code, it will allow you to train different commands in different portions, and take each command is stored between 0, 1, 2, 3. So you can see here train, load, clear, record. So with this, you'll be able to train your module to be able to store up to 80 commands, each saved as 0, 1, 2 down to 80. Now, knowing how to train it using what the resources from Elec house themselves, what you need to do is to come and initialize your LED pins, your servo objects, and then create or define the variables that are holding up your voice commands. Then you have to be able to use more than 7 commands at a time. In your setup, you obviously initialize and also attach your servo pins, and you start up with loading the first set of instructions into your module. Now, moving to void loop, you use the switch case to pick out each of the different instructions. So in this case, you have case parlor, case dining, case kitchen, case garage, and case bedroom. Now, if any of these are actually true, that is, if the module detects any of these of your statements, it should turn the parallel underscore state to true. That's the boolean I created earlier to true, and then clear all of the previously loaded instructions. After clearing all of the previously loaded instructions, it's supposed to now create a new set of instructions, or rather load the new set of instructions which you have already recorded beforehand, which in this case are door open, door close, light on, and light off. Now, what it happens is that if the parallel underscore state is turned to true, then later down after the case, the switch case, if the parallel state is turned to true, then it detects which of the different commands you state, which in this case you can have both. 1 is equals to 5. If you go back up, you would have 5 being light underscore on. So if you perform after saying parallel and it detects you said light on, then what would happen is it would perform the function, which is digital right LED parallel high, which states that the light should come on, and then clear. After clearing, it goes back and loads all of the previous commands again, and that's how it continues to loop. So as I said before, parallel, then you say what command you want, and then it loops back again and again and again. So that's essentially how the code works. So you multiply that across the different things you want to control, and just keep on increasing the number of switch cases and the number of instructions that you want to use. So with that figured out, I got to assembling all of the electronics, power supply, and uploading the code. After assembling everything together, here's how it looks and some live testing clips. Now, as I said before, because of my bad tonation, I could only use numbers which are single syllable most of the time, 1, 2, 3, 4, which were what I used to store the commands instead of using lights on, parlor, lights off, because I had issues saying the same statement again and again and again, and it's just significantly easier to save time by using syllables when you are doing the testing stage. Zero, 5, 0, 6, 0, 9, 0, 10, 3, 6, 4, 7, 4, 8, 2, 8, 3, 9, 3, 5, 0, 0, 5, 0, 0, 4, 8, 4, 5, 4, 7. If you made it this far, thank you for watching. Drop a comment on your favorite part of the build and future project ideas. I'd love to see them. Want to see me rebuild my gesture controlled robot or vehicle that was literally assassinated by a kid, or how I rebuilt a robotic arm in record time? Check those out. See you in the approaching future. 0.